7.3, number 19, says nearly one-half of Americans aged 25 to 29 are unmarried. How large a sample is necessary to estimate the true proportion of unmarried Americans in this age group within 2.5 percentage points with 90% confidence? So let's figure out what they want us to calculate here. So it says how large a sample is necessary. How large a sample? They want to know our sample size here. Now we know, I think you guys have learned two formulas for sample size so far. So we need to figure out which one it is. It says how large a sample size is necessary to estimate the true proportion. You see proportion, you know that's p hat and q hat. So you're going to be using the formula for n, for finding n that has p hat and q hat in it. So n equals p hat times q hat times z of alpha over 2 over e squared. So that's how we calculate our n. So now let's find the necessary pieces. So we need p hat, we need q hat, we need our error, our confidence level, and our z of alpha over 2. So let's start from the beginning. It says nearly one-half of Americans ages 25 to 29 are unmarried. So there's a percentage right there. Nearly one-half is 50%, but let's figure out what that is, whether it's p hat or q hat. It says how large a sample is necessary to estimate the true proportion of unmarried Americans, and nearly one-half of them are unmarried. So p hat is 0.5 or 50%, but we have to change it to a decimal since we want to do math with it. And remember, q hat is 1 minus p hat, which is, again, 50%. Then it says, in this age group, within 2.5 percentage points. So they want to calculate n within 2.5%, but we need to change it to a decimal to work with it. So it's 0.25, and that's going to be our error because they want us to guess it within 2.5%. So 0.025, and then our confidence level is 90%. So let's go find our z of alpha over 2 based on 90% confidence level. Here we have 90%, and remember z's at the bottom here for our t distribution, and all the way down to the bottom, 1.645. So z is 1.645. So now let's calculate n. We have everything we need. So n is equal to p hat times q hat times z of alpha over 2 is 1.645 over e, which is 0.025 squared. Now let's put it in our calculator. 0.5 times 0.5 times 1.645 divided by 0.025 squared. So we have 0.5, let's do 0.5 times 0.5 times parentheses 1.645 divided by 0.025 squared. And that gives us, remember round up because we can't survey 0.4 people. So our answer is 1,083 people. Now keep in mind, if you do round your z of alpha over 2 and you use 1.65, you're going to get 1089. So I believe the back of the book says 1089, but depending on what your professor wants for your z of alpha over 2, you might get two different answers, but either one is good. So with z of alpha over 2 being 1.645, n is 1083. But if z of alpha over 2 is equal to 1.65 if you round, then n is 1089. Yes, 1089.